Have you ever wondered how a thermometer measures temperature? Just a simple object, yet it holds the key to understanding our world's temperature variations. It's a common tool, but the science behind it is anything but ordinary. From the rising and falling of the liquid inside to the way it responds to heat, there's a lot to uncover about this humble instrument. So, let's embark on this exciting journey of discovery. Today, we will unravel the mystery behind this everyday object that we often take for granted. To understand how a thermometer works, we first need to grasp the basic principle it operates on. This principle is known as thermal expansion. Now, what does that mean? Well, simply put, thermal expansion is the process where substances expand when they're heated and contract when they're cooled. Think of it like a dance, with the molecules of a substance moving faster and spreading out as they heat up, and slowing down, getting closer together as they cool down. This is a fundamental principle that makes a thermometer work. The liquid inside a thermometer, often mercury or colored alcohol, expands when it's heated and contracts when it's cooled. As it expands, it moves up the narrow tube, and as it contracts, it moves down. So the movement of the liquid inside a thermometer is a visual representation of this principle in action. Now that we understand the basic principle, let's delve deeper into the inner workings of a thermometer. A typical liquid in glass thermometer, the kind you might find in a doctor's office or your own medicine cabinet, is a marvel of simplicity and precision. At its core, it consists of three main components: a bulb filled with a liquid, a narrow capillary tube, and a calibrated scale. The bulb at the base of the thermometer holds a specific quantity of liquid, often mercury or colored alcohol. This liquid is chosen for its predictable response to temperature changes. When the bulb is exposed to heat, the liquid inside warms up and expands. Because the bulb is sealed and the liquid has nowhere else to go, it's forced up into the narrow capillary tube. This tube is thin, almost hair-like, and the slightest change in the volume of the liquid causes a noticeable shift in its level. As the liquid expands with the heat, it climbs higher up the tube. Conversely, when the bulb is cooled, the liquid contracts, reducing its volume, and descends down the tube. But how does this movement of liquid translate into a temperature reading? That's where the calibrated scale comes in. The scale, usually etched onto the glass or printed on a backing behind the tube, corresponds to the movement of the liquid. As the liquid rises or falls, its level aligns with different markings on the scale, each representing a specific temperature. The beauty of this system lies in its directness and consistency. There are no batteries, no digital components, just the predictable physics of thermal expansion and contraction. The liquid inside the thermometer acts like a physical representation of temperature, its movements painting a clear visual picture of how hot or cold it is. In a nutshell, a thermometer measures temperature by translating the expansion and contraction of a liquid into a numerical value on a scale. This simple yet ingenious device allows us to take the invisible concept of heat and cold and turn it into a number we can understand and use. So, the next time you use a thermometer, take a moment to appreciate the clever science at its heart. Can you think of everyday objects that change their shape or state when exposed to heat? This phenomenon, known as thermal expansion, is a common occurrence in many aspects of our daily lives. For instance, have you ever noticed how the metal lid on a glass jar becomes easier to open when you run it under hot water? That's thermal expansion in action. The heat from the water causes the metal lid to expand slightly, breaking the seal and making it easier for you to twist open. Similarly, another example can be seen in railway tracks. During the sizzling summer months, the metal tracks expand due to the intense heat. This is why there are small gaps left between each section of the track. These gaps allow room for the tracks to expand without causing any distortions or derailments. Even the bimetallic strip in your thermostat is an example of thermal expansion. The strip is made up of two different metals, each with its own unique rate of expansion. When the room heats up, one metal expands more than the other, causing the strip to bend and activate the cooling system. So you see, thermal expansion is not just a scientific concept, but a part of our everyday lives. From opening stubborn jar lids to ensuring safe railway travel, and even in controlling our indoor temperature, the effects of heat are all around us. Heat plays a crucial role in these changes, causing objects to expand and contract just like the liquid in a thermometer. Have you ever wondered why it's colder in the early morning and late evening compared to the middle of the day? Well, the answer lies in the rotation of our planet, Earth. As the Earth spins on its axis, it completes one full rotation every 24 hours. This rotation is the reason we experience day and night. But did you know that it also significantly influences our daily temperature patterns? To understand this, visualize a sunny day. When the sun rises in the morning, it's low in the sky and the sunlight hits the earth at a shallow angle. This spread out or diffuse sunlight has to travel through more of the Earth's atmosphere before reaching us. As it travels, some of the sunlight is absorbed or reflected by the atmosphere, leaving less to heat the Earth's surface. Consequently, we experience cooler temperatures in the early morning. As the day progresses, the sun climbs higher in the sky and by noon, it's directly overhead. Now, the sunlight is hitting the Earth at a steeper angle, concentrating the light and heat over a smaller area. Also, because the sunlight has less atmosphere to pass through, more of it reaches the Earth's surface, resulting in higher temperatures. As the sun begins to set in the evening, once again, the angle of sunlight becomes shallow, and the process that occurred in the morning repeats itself, leading to cooler temperatures. It's fascinating, isn't it? The Earth's rotation, something we don't even feel, has such a profound impact on our everyday lives. It affects not only the cycle of day and night, but also the ebb and flow of our daily temperatures. So, the Earth's rotation not only gives us day and night, but also plays a significant role in determining our daily temperature patterns. It's just another reminder of the intricate interplay between the natural world and our daily experiences.